Matt Dragon, and I'll be your narrator as we listen to a typical exchange between a very well-prepared applicant and an FAA examiner for the private pilot airplane check ride. This is just one example of a typical practical test. You should review the ASA Oral Exam Guidebook for more types of questions that may be asked during your check ride. So, you've studied for long hours, invested hard-earned dollars, your instructor has signed you off, and the big day is at hand. You're ready for the private pilot check ride. Let's talk a little about what you can expect during the test. First, remember you'll likely be nervous. You're only human. Most people don't like to fail, so being tested and judged can make us nervous. Second, remember that everyone wants you to pass. You obviously want to pass. Your instructor wants you to pass. They signed you off and staked their reputation on it. And last but not least, the FAA designated examiner wants you to pass. A bunch of people feel confident you have the tools and talent to pass, so don't sweat it. Remember these 2 points. The FAA wants you to be a safe and competent pilot and has established a set of standards that must be met to issue a private pilot certificate. These are called practical test standards. Your instructor has used and exceeded these standards in your training and in your preparation for the practical test, so you're more than ready to go. So, what are the practical test standards? This is a book published by the FAA, and what's in it will be the basis for everything on the test. Your designated examiner might not follow the exact sequence in the book, but is required to cover everything in it during your check ride. It's important for you to understand exactly what might cause you to fail the check ride. I know it's an unpleasant thought, but sometimes when you know what failure looks like, you have a better time visualizing success. Again, the FAA wants you to be a safe, competent pilot with the proper skills, knowledge, and judgment to operate an aircraft. If you don't demonstrate sound judgment, or if the successful outcome of any of the required tasks are seriously in doubt, you can fail this test. If you exceed a tolerance, such as the 100-foot plus or minus altitude standard, but correct it immediately, that's what the examiner wants to see. If you fail to take action or repeat this error again and again, the examiner will see a pattern and begin to seriously doubt your ability to perform this task, and you will fail. The examiner takes into consideration the flying conditions during the check ride. So on a windy, turbulent day, they will anticipate some possible deviation. But a pattern of failing to maintain altitude or heading, or just not taking any corrective action, indicates a problem. Remember to practice good visual scanning and collision avoidance. This is one of 10 special emphasis areas to which the examiner will be paying particular attention. These areas aren't part of any one maneuver, but rather must be demonstrated throughout the entire flight. They include positive aircraft control, positive exchange of flight controls, stall spin awareness, collision avoidance, wake turbulence avoidance, land and hold short operations, runway incursion avoidance, controlled flight into terrain awareness, aeronautical decision making, and the use of checklists. On the day of your test, be prepared for all the administrative details by putting together a packet of materials the examiner will want to see. This should include your logbook, a form of ID such as your driver's license, your student pilot license and medical certificate, the FAA 8710 form signed, your knowledge exam test results, a printout of current weather data for that day, and aircraft information such as the airworthiness certificate, the FCC radio license, weight and balance information, and the aircraft's logbook, indicating annual inspections. Having this information organized and ready to go will set the tone for the rest of the practical test. If you're not organized, it will send an immediate message to the examiner and it will be difficult to recover from this perception. The first step in any check ride is for the examiner to confirm you're qualified by reviewing your paperwork and logbook entries. Next, it's likely you'll get a pre-test briefing explaining how the test will be conducted, what the standards are, and what the possible outcomes are. Then he or she will announce that the test has begun. Most examiners try to put you at ease, as they understand nervousness can be par for the course. Some will collect their Checkride fee as part of the overall paperwork review. Others will wait until the end when they issue the certificate. Be sure to have your payment ready. The examiner's fee is separate from the aircraft rental. The examiner will have given you a specific flight to plan when you scheduled the Checkride. Make sure you've done your homework and retrieved the current weather and terminal forecasts along your planned flight path, as well as selected alternates or diversions. The cross-country is the focal point for this test because everything is related to it. How you determine if the aircraft is airworthy for this flight, your pilot currency requirements for this flight, how you arrived at a go, no-go decision for this flight, describing the type of airspace you'll encounter on this flight and how it could affect you, and so on. Using the cross-country makes the test as practical as possible, which is the goal. The FAA wants to see how you will operate as a licensed pilot once they issue your ticket. This pre-flight discussion generally takes an hour and a half to 2 hours. Most examiners will not separate the oral from the flight test. In fact, the FAA has asked them not to. Examiners have been instructed to consider the Checkride as one big practical test, not an oral and a flight test. The FAA strongly encourages examiners to use scenarios during testing. This means wording questions to test application and correlation learning, rather than asking a lot of what questions, which only reveals rote learning. You can expect hows and whys. For example, instead of what is maneuvering speed, an examiner will ask something like, explain the significance of maneuvering speed. Remember, this is an educational program, so relax. We cover much more than the average examiner will question you on in any given test situation. Now, let's join our applicant and examiner in the briefing room and listen as the Checkride gets underway.
Hi, Dave. I'm Robin. Nice to meet you.
Hi, Robin. Good to meet you. Robin, all your required paperwork appears to be in order. Looks like you're fully prepared for this private pilot airplane, single-engine land Checkride. Let's have a seat over here where we can talk privately. Now, the restrooms are just around that corner. Please feel free to use the facilities when you need to. And go ahead and lay out anything you'd like to have access to while we're talking, including your materials for the cross-country that I asked you to prepare. As I start asking you questions, I'd like you to try to answer to the best of your knowledge. Now, if you're stumped, I'd like you to try to derive an answer. Sometimes proving your resourcefulness will be enough, while other times, I expect you to have the knowledge committed to memory. Questioning will continue throughout the entire test. This includes the oral examination taking place right now in the briefing room, out at the pre-flight, during the flight, and post-flight. Your knowledge, it's not in question here. You've already passed the knowledge test. We're here to test the practical application of that knowledge. I'll let you know if you're in error at any point so we can stop and talk about it. Robin, there are 3 possible outcomes to today's test. If you meet all the standards, I'll issue a temporary pilot certificate. If we find an area that doesn't meet the standard, I'll issue a notice of disapproval and ask you to go back and get additional instruction in that area from your instructor. Then you'll be retested at a later date in that area before being issued a pilot certificate. Finally, if we're not able to complete today's test for an unforeseen reason, say weather or mechanical problems, I'll issue a letter of discontinuance. This will allow us to resume the test from where we left off. Do you have any questions before we get started?
No, I think I'm ready.
Okay, the test has begun and we're out flying today. And how's the weather looking for us?
Here, the examiner invites the applicant to give a broad overview of the flying conditions and orientation for the planned flight. Examiners frequently start with a general discussion about the cross-country to put you at ease. It will be an easy topic for you to talk about since you spent a lot of time preparing it. The examiner will ask you where you're going, how the overall weather looks, and how you planned it. From this conversation, it's an easy transition into more specifics on the aircraft, you as the pilot, and the weather. Then the examiner will return to the cross-country planning to look at such specifics as performance and limitations of your airplane, the navigation log, and so on. All this is done with the goal of determining whether you'll be safe when you leave as a newly minted pilot. Track 2, Certificates and Documents. Using the cross-country you planned for the Checkride, the examiner will bring up specifics such as certificates and documents necessary to keep the flight within regulations.
Robin, explain to me some of the limitations that apply to you as a private pilot on today's flight.
Well, one of the biggest limitations is that I can't carry passengers or property for compensation or hire on this flight.
Now, is splitting the cost with passengers considered compensation?
Not necessarily. We can share the costs as long as I don't pay less than a proportional share of the operating expenses of the flight, and only if those expenses involve fuel, oil, airport expenditures, rental fees, the direct costs of the flight itself.
What else can you do as a private pilot?
Well, if it's a passenger-carrying flight sponsored by certain charitable organizations, I can be PIC. Also, certain search and rescue operations allow me to get reimbursed for expenses associated with the flight. Once I log 200 hours of flight time, I can demonstrate an aircraft in flight to a potential buyer as an aircraft salesperson. And once I meet the experience requirements, I can be PIC of an aircraft towing a glider.
Okay. Could I use this flight to get to a business meeting at the destination?
Yes, I can be pilot in command since it would be incidental to the business, and I'm not carrying passengers or property for compensation, but I couldn't charge for someone to sit in the seat next to me.
Okay, let's talk about the airplane we'll be flying today. What category aircraft will we be in?
We'll be flying an airplane. A category is a broad classification of aircraft, like airplane, rotorcraft, glider, and lighter than air.
What class and type of airplane is it?
We're going to use a single-engine land airplane, a Cessna 152. Class is a further classification within a category having similar operating characteristics. Examples include single-engine land or multi-engine land. Type is a specific make and basic model of aircraft, such as Cessna 150 or Boeing 737.
Can you, as a private pilot with a single-engine land on your certificate, fly any single-engine land aircraft?
Yes, as long as it weighs less than 12,500 pounds. For something bigger, I'd need a type rating. But in order to fly high altitude, high performance, complex or conventional gear airplanes, I'll need some additional training and an instructor endorsement in my logbook.
How will you know if the airplane you want to fly is a high performance or complex aircraft?
Well, let's see. If it has an engine that is more than 200 horsepower, like a Piper Seneca 2, it's a high-performance airplane. If it has a retractable landing gear, flaps, and a controllable pitch propeller, like a Cessna 182 RG, then it's a complex airplane.
That's correct. Let's talk about what you'll need to do to stay current as a private pilot. What are the requirements?
First of all, I need to take a flight review every 2 years in an airplane with an instructor who endorses my logbook, certifying I satisfactorily completed the review. Second, every 90 days, I need to make 3 takeoffs and landings as the sole manipulator of the airplane. Third, if the aircraft is a tail dragger, or I'm planning on flying at night with passengers, the landings must be made to a full stop.
You've mentioned your logbook a couple of times. Is it required?
Well, all pilots use them as a way to organize and document flight time. You could use a different method, but I think most opt for logbooks. Either way, you must be able to prove training and experience requirements have been met.
Let's talk about you, the pilot, for the moment. What class medical do you need to exercise the privileges of a private pilot certificate?
I need a third-class medical.
How long is it valid?
It expires at the end of the 36th month after the month of the date of the examination because I'm under 40. If I were older than 40, it would expire at the end of the 24th month.
Okay, let's move on. What documents are required on board the aircraft prior to today's flight?
4 documents. I use the acronym AARO to remember them. A stands for Airworthiness Certificate, R stands for Registration Certificate, O for Owner's Manual or Operating Limitations, and the W is Weight and Balance.
Those memory joggers, they do the trick, don't they?
Can't live without them.
What is the airworthiness certificate and how long does it remain valid?
It's issued by the FAA once the aircraft has been inspected and confirmed it meets all the regulatory requirements. It's valid for as long as the aircraft receives the required maintenance and is properly registered. The aircraft must also meet the requirements of the original type certificate.
Okay, where is the airworthiness certificate usually kept in the aircraft?
It needs to be visible to passengers or crew when the aircraft is operated. In the airplane we're flying today, it's in a plastic envelope taped to the left side of the fuselage above the pilot's ears.
What about inspections for this aircraft? How many must occur and when?
There's an annual inspection every 12 months, which is required for all airplanes, as well as a 100-hour inspection, required because this airplane is used for flight instruction. 100 hours are required for flights that are for hire.
Who's responsible for ensuring the aircraft is maintained and in an airworthy condition?
The owner or operator.
Okay, where's the weight and balance data for your aircraft and how can I tell if it's correct?
It's normally in the Pilot Operating Handbook or Airplane Flight Manual. It's updated whenever equipment is added or removed from the aircraft, and you should always use the most recent data.
How can you determine if an aircraft has all the required placards on board?
The Pilot Operating Handbook or Type Certificate data sheet will list the required placards.
What if you have inoperable or broken equipment on the aircraft? Can you conduct flight operations?
Yes, under some specific conditions, like a minimum equipment list, when the inoperable instruments or equipment aren't essential for safe flight.
What is a minimum equipment list?
The MEL is an FAA-approved list of equipment and instruments for a specific aircraft that spells out whether a flight can legally be made with something on board that isn't working. It's not something to be used in flight. It's a reference for pilots on the ground, deciding whether they can make a flight with some piece of equipment not working in the aircraft.
Do all airplanes have an MEL?
No, the FAA considers the MEL, along with the letter of authorization, to be a supplemental type of certificate. The aircraft owner can request these. The LOA has to be on the board of aircraft for the MEL to be valid, and both documents apply only to that specific airplane model and tail number.
What would you do if you found something or inoperable on your pre-flight inspection and the airplane you were flying didn't have an MEL?
Well, if I find inoperative equipment during my pre-flight inspection or prior to departure, I must cancel the flight, get the item fixed prior to the flight, or defer maintenance on the item. First, I determine if the inop component is required by regulation as part of DAE VFR equipment, if an airworthiness directive requires it, or if it is specifically required for a certain operation. If none of those apply, then it must be deactivated or removed. In either case, it must be placarded inoperative. If I decide to defer maintenance, it's my responsibility as PIC to ensure a safe flight can still be made.
Robin, a couple more questions on aircraft maintenance requirements and then we're going to move on. What are airworthiness directives?
Okay, an AD is what the FAA uses to notify aircraft owners and others of possible unsafe conditions due to design defects, maintenance, or other causes. They also specify the conditions under which the airplane may continue to be operated.
Do you have to get these done or are they just recommendations?
These are regulatory, so compliance is mandatory. The owner or operator of the aircraft is responsible for getting these done.
When might you run into a special flight permit?
These are issued for an aircraft that might not meet airworthiness requirements but is capable of safe flight. I might see this when I have to fly an aircraft to a base where repairs and maintenance are performed. I could also use these when delivering or exporting an aircraft, flight testing new production aircraft, evacuating aircraft from areas of pending danger, or conducting customer demo flights in new production aircraft that have passed flight tests.
Good job, Robin. Let's move on right now and talk about weather.
Robin is starting out strong with her demonstrated understanding of certificate and document requirements. She also needs to know where to find the required maintenance and equipment inspections in the aircraft and engine logbooks for the Checkride airplane. These include the annual inspection, 100-hour inspection, ELT inspection, and battery expiration date, transponder certification, and compliance with ADs. The logbooks for rental aircraft are often kept in the maintenance hangar. Ask your flight instructor to show you where everything is before you meet with the examiner, or how to handle these details if the check ride will take place at a different airport. Track 3, Weather Information. The examiner is now going to test Robin's understanding of weather and how it affects her flying decisions.
Okay, Robin, let's move on to some other questions about weather. How did you learn about today's weather?
Well, I called flight service using 1-800-WX-BRIEF and got a standard weather briefing. If I called them earlier, I would have asked for an abbreviated briefing. Last night, I got a preliminary look at the weather asking for an Outlook briefing.
So what information did the briefer give you today?
A number of things were in today's briefing. Adverse conditions, whether VFR flight is not recommended, a synopsis, the current conditions, en route forecast, destination forecast, winds aloft, any NOTAMs, and any ATC delays. If I wanted to, I could get the status of military training routes and MOAs, a review of the printed NOTAM publications, approximate density altitude information, customs procedures, ADIS rules, and search and rescue, although I hope we won't need that. Oh yes, you can also get LORAN and GPS RAIM availability.
Tell me how we're going to go about gathering weather while we're en route.
I can call EFAS, known as Flight Watch, on 122.0. This gives weather advisories pertinent to our type of flight, which is VFR, our route and altitude. Flight Watch is also the central collection point for PIREPs.
Tell me how we're going to stay abreast of any potential hazard conditions while we are in flight.
I'll listen to in-flight aviation weather advisories on the HIWAS frequency. This broadcast includes SIGMETs and AirMets.
Okay, Robin, what's the difference between a SIGMET and an AirMet?
A SIGMET warns pilots before and in flight of non-convective weather that may be hazardous to all aircraft. It covers a forecast period of up to 4 hours for events like severe icing, severe turbulence, dust storms, sandstorms, and volcanic ash. An AirMet covers less extreme events, the kind that affect light aircraft rather than the big ones, with details about IMC, mountain obscuration, turbulence, strong surface winds, icing, and freezing levels.
Good job. Okay, I asked you to plan a trip from Arlington, Texas to Abilene, Texas. Let's go over the weather for your flight. First, explain a METAR and how's it useful?
METARs are aviation routine weather reports based on hourly surface observations of airport conditions.
What does it tell us about our departure and our destination airports?
Well, for Arlington Municipal, it shows the wind is from 340 degrees at 10 knots. Visibility is 10 miles, and the sky is clear below 12,000 feet. Temperature is 25 degrees Celsius, and dew point is 10 degrees Celsius. The altimeter setting is 29.98 inches. For our destination Abilene, it shows that the wind is also out of the north from 350 degrees at 9 knots. The visibility is 10 miles, and the sky is clear below 12,000 feet. Temperature is 23 degrees, and dew point is 8 degrees. Altimeter setting is 29.96.
Why do we need to know the dew point?
Well, dew point is the temperature to which a parcel of air must be cooled to become saturated. Once the air has become saturated, it can no longer hold moisture in a vapor state. In other words, the moisture will condense and become something we can see, such as clouds, fog, etc., which are ideal conditions for carburetor icing.
Speaking of which, let's talk about fog and what are some of the ways fog may form?
It can form when air is cooled to its dew point or when moisture is added to already cool air.
Okay. What does the TAF indicate for the departure and destination airports?
The Terminal Area Forecast, also known as the Terminal Forecast, which covers a 5 statute mile radius around our departure airport for the next 24 hours, looks really good. It's indicating that from 1600 Zulu, the wind will be 350 at 8 knots, visibility will be better than 6 miles, and the sky will be clear. And it pretty much stays the same for the other time periods. The destination weather for Abilene indicates the winds will be from 330 degrees at 13 knots, visibility will be over 6 miles, and the sky clear. The rest of the forecast is about the same. So great weather for the next 24 hours.
Not bad. Let's talk about some of the bad weather that just didn't show up in today's forecast. If it had been raining, what are some of the concerns you'd have for flying in the rain?
Besides reduced visibilities and cloud clearances, if it's raining, I also have to watch the temperature. If the wing is cold enough or the raindrops are supercooled, then the rain will freeze on impact, resulting in structural icing.
And we all know the consequences of icing. How about frost? Is this as dangerous as icing?
Yes. Frost can change the surface of a wing, which might cause early separation of airflow and loss of lift. Even a little bit of frost should be removed before flying.
Here in Texas, it's unusual to get a forecast that doesn't include at least a chance of thunderstorms. Why is that? What factors must be present for a thunderstorm to form?
Thunderstorms need a source of lifting, unstable air, and moisture to be present, and at least one of these conditions is present almost daily around here.
What is different about a microburst? When and where are these most likely to occur?
A microburst is a fairly short-lived downdraft of air that's associated with thunderstorms and convective activity. They can be hazardous to planes that are taking off and landing because when this downward plunging air hits the ground, it spreads out in all directions, potentially creating horizontal and vertical wind shears that aren't detectable by the pilot or equipment on the ground.
Let's talk about wind shear. What is it and where is it most likely to occur?
Wind shear is just an abrupt change in wind speed or direction at some level of the atmosphere. It can be a vertical or horizontal shift. Some places to find it would be at the boundary of a temperature inversion or near a frontal zone or thunderstorm.
Robin, almost as dangerous as wind shear, but something we don't have much of here in Texas. Tell me about mountain waves.
Mountain wave refers to turbulence that can occur on the lee side of a mountain as air blowing across the ridge develops a sort of wave flow, similar to the surface of water. The turbulence can extend well beyond the mountain range and gets worse as wind speeds increase. It's one of the reasons pilots should get some additional training before flying in the mountains.
Robin, very good. I'm glad we're not dealing with any of these conditions today. Let's talk some more about the weather briefing. If your destination airport didn't have a TIF, how would you have to determine the forecast at the time of the arrival?
I would use an area forecast.
What can you get from an area forecast?
It's a forecast of VMC, clouds, and general weather conditions over an area the size of several states. I use it along with in-flight weather advisories to better understand the complete weather picture. It helps me determine forecast en route weather and interpolate conditions at airports where no TAFs are issued. For north central Texas, it says that for the western half of the area, the sky will be clear or scattered clouds, and the outlook is VFR. For the eastern half of the area, the remnants of the front that pass through here are still present. It indicates the ceiling is forecast to be overcast at 1,000 feet with tops at 5,000 feet. Visibility will be 3 to 5 miles. From 1300 Zulu, the ceiling will be broken with 5/8 to 7/8 coverage at 2,000 feet. From 1500 Zulu, the ceiling will become scattered at 3,000 feet and the outlook will be VFR.
So it looks like pretty good weather for today's flight. What is the winds and temperatures aloft forecast indicating for today's flight?
Today's winds aloft forecast is for use from 1700 to 2100 Zulu. Data was based on an observation at 1200 Zulu. No observation is made at 3,000 feet since it's too close to station elevation, but at 6,000 feet it indicates the winds are 350 true at 33 knots and the temperature is plus 10 degrees Celsius.
Explain the significance of the information from the winds and temperature aloft forecasts.
These forecasts can tell you the most favorable altitude to use based on winds and direction of flight. They can also indicate areas of possible icing by noting temperatures between plus 2 degrees Celsius to minus 20 degrees Celsius. Temperature inversions can also be determined. Altitudes where turbulence might be expected can be detected by abrupt changes in wind direction and speed at different altitudes.
Let's talk about weather charts. How and when would you use a surface analysis chart?
I'd use it in all my cross-country pre-flights because a surface analysis chart provides a ready means of locating pressure systems and fronts and gives me an overview of winds, temperatures, and dew point temperatures at the time on the chart.
Good, very good. Tell me about the way air will generally flow around high and low pressure systems in the Northern Hemisphere.
Around a low pressure center, it will flow inward, upward, and counterclockwise. Around a high, outward, downward, and clockwise. Basically, air is sinking and piling up over a high. As this air flows outward, it moves into areas of low pressure, where air tends to push its way up.
Robin proved she has a good operational understanding of aviation weather and weather services, which is critical to making sound go, no-go, and diversion decisions. So far, this is a rock-solid Checkride. In addition to what you've heard here, be prepared to respond to questions on when you'd decide to divert or opt to stay on the ground.
Very good. It's important to know what kind of air you'll be flying in before you set out so you can anticipate the conditions. What other charts might you use for your pre-flight preparations?
I'd look at a weather depiction chart because it gives me a broad overview of the flying conditions at the time on the chart, and I can get a bird's eye view of areas of favorable and adverse weather conditions from this chart. A radar summary chart helps me in pre-flight planning by identifying general areas and movement of precipitation and/or thunderstorms. We already talked about the usefulness of the winds and temperatures aloft chart to help decide on the best altitude for a flight you're planning. The convective outlook chart depicts the areas forecast to have thunderstorms, so this is something I'll definitely want to look at. The significant weather prog charts portray forecasts of a certain weather conditions at specific times. They provide forecast information from the surface to 24,000 feet. I use all these charts to build a complete weather picture.
Okay, sounds like you have a great grasp of the charts available to you. Let's talk a little more about the weather services that are available out there. How would you use ASOS, AWOS, and ATIS?
ASOS stands for Automated Surface Observing System. It's the main U.S. surface weather observing system. It provides minute-by-minute observations, generating METARs and other aviation weather information. It transmits over a discrete radio frequency or the voice portion of a nav aid. Also, there's often a phone number I can call to access the recording. AWOS stands for Automated Weather Observing System and broadcasts local minute-by-minute weather data directly to the pilot. These are generally older and being replaced by ASOS. ATIS is a continuous broadcast of recorded non-control information in high-activity terminal areas. It helps controllers be more efficient and keeps the radio less congested because it automates the transmission of needed weather information. It's continuously broadcast over a discrete radio frequency or the voice portion of a local nav aid. I'd use ASOS or AWOS to get in-flight information and listen to the ATIS before entering or departing an airport area.
Okay, that all sounds very good. Let's check a couple of other items you have here. What's the significance of NOTAMs?
These basically consist of time-critical information that isn't known far enough in advance to publish on the charts or other publications. It's the kind of information that could affect my decision to make a flight. NOTAMs are published in a book called, surprisingly enough, Notices to Airmen. Subscribers can get the book every 28 days, and it's available on the internet.
Give me some examples of the kind of information contained within a NOTAM.
They can include information like airport or runway closures, changes in the status of nav aids, radar service availability, and other important information for en route, terminal, or landing operations.
Okay. What NOTAMs exist at our destination airport today?
Not too many. The only NOTAM I see for ABI is this one, which indicates that the ABI TACAN is out of service.
What types of NOTAMs will be omitted in a pilot briefing if you don't specifically request them?
Distant NOTAMs and FDC NOTAMs Already published aren't included unless I specifically ask for them. Also, local NOTAMs are only distributed locally and aren't attached to weather reports, but they're usually filed by flight service, and I have the option to request that they look these up.
Very good, Robin. Very good. Let's move on.
Robin proved she has a good operational understanding of aviation weather and weather services, which is critical to making sound go, no-go, and diversion decisions. So far, this is a rock-solid Checkride. In addition to what you've heard here, be prepared to respond to questions on when you'd decide to divert or opt to stay on the ground. Track 4, Performance and Limitations. The pre-flight weather briefing complete, the examiner now shifts gears to see how Robin determines the aircraft's performance and limitations.
Okay, Robin, now let's talk about today's weather and how it's going to impact the airplane's performance. How does today's weather relate to standard atmospheric conditions at sea level, and why do we need to consider this?
Standard atmospheric conditions are 15 degrees Celsius and 29.92 inches mercury. We're a little warmer at 25 degrees Celsius, with the pressure a little higher at 29.96. But we aren't dealing with anything like high-density altitude conditions. It's good to know how today's weather compares to standard atmospheric conditions because your aircraft's performance numbers are derived under specific conditions that may not apply to your particular flying day. An atmospheric standard is just used as a baseline to find accurate performance data.
What is pressure altitude and how is it useful?
Basically, pressure altitude is useful for determining aircraft performance. I compare a given day's altimeter setting with the altitude I get when selecting a standard day's altimeter setting, and this gives me meaningful performance numbers that take into account differing barometric pressures. So to find pressure altitude, I just dial in 29.92 and read the indicated altitude.
You mentioned a concern for density altitude when you compared today's conditions against standard. What is density altitude?
Density altitude is pressure altitude corrected for non-standard temperature. Basically, it refers to a hypothetical altitude that represents what kind of performance you would expect under given conditions of air density. In other words, density altitude reflects how an airplane would act under given conditions. At a high-density altitude, the airplane will act as though it was actually at that altitude, even though it may just be hot at sea level.
What factors affect air density?
Altitude for one. The higher the altitude, the less dense the air. Also, temperature has an effect in that the warmer the air, the less dense it is. Finally, there is humidity. The more humid, the less dense the air. I need to be particularly concerned at airports that are high, hot, and humid. This is where I'll find high-density altitudes and therefore lower aircraft performance.
How can you determine what the density altitude is today?
Well, two ways. I can use my flight computer to determine this by simply plugging in the pressure altitude and outside air temperature. Or I can use a density altitude chart. Today's density altitude at Arlington is 1,867 feet.
Okay, how does air density affect aircraft performance?
The air density will affect the amount of lift produced by the wings, the power output of the engine, the propeller efficiency, and the total amount of drag. An increase in density altitude results in an increased takeoff distance, a reduced rate of climb, an increased true airspeed on approach and landing, and an increased landing roll distance.
What factors, Robin, cause the difference between indicated airspeed and true airspeed?
Temperature and pressure altitude. As you fly higher in the atmosphere, true airspeed increases over indicated airspeed.
How would this higher true airspeed at altitude affect your approach and landing if we were at a high density altitude airport?
The indicated airspeed used on approach and landing won't change with altitude because the airspeed indicator senses the same drop in air density as the wing. However, because true airspeed is higher, it means my airplane will actually land at a higher airspeed than indicated, so I'll need to allow for that in my planning as the landing distance will be increased. The same is true for takeoff. Takeoff distance will increase.
How about today's winds? What effect will these have on the aircraft performance?
Today's winds are pretty light on the surface, 340 at 10 knots, and much stronger but in the same general direction at 6,000 feet from 350 degrees at 33 knots. For takeoffs, a headwind increases airplane performance by shortening the takeoff distance and increasing the angle of climb. A tailwind decreases performance by increasing the takeoff distance and reducing the angle of climb. For landings, a headwind increases airplane performance by steepening the approach angle and reducing the landing distance. A tailwind decreases performance by decreasing the approach angle and increasing the landing distance. For cruise flight, a headwind decreases performance by reducing ground speed, which increases the fuel requirement for the flight. A tailwind increases performance by increasing the ground speed, which reduces the fuel requirement for the flight.
Okay, Robin, what performance charts did you use in today's pre-flight preparations?
I used the takeoff distance chart to calculate my normal takeoff ground run. If I had an obstacle to clear, I could also calculate obstacle clearance ground run from this chart. I used the rate of climb performance chart to calculate rate of climb. I also used the time, fuel, and distance to climb chart to calculate what it would take to climb to cruise altitude. The cruise performance chart was used to calculate percent brake horsepower, true airspeed, and fuel consumption. And I used the landing distance performance chart to calculate my normal landing distance as well as distance required to clear a 50-foot obstacle at my destination.
Will the performance charts always provide accurate information concerning aircraft performance?
For the most part, yes. But there's a lot of variables that affect the performance stated in the charts. The information they provide is based on flight tests conducted under normal operating conditions, using average piloting skills with the airplane and engine in good operating condition. Any deviation from those conditions will affect performance.
And what affects the performance of an aircraft during takeoffs and landings?
Air density, surface wind, runway surface, upslope or downslope of runway, and weight.
Okay, Robin, show me how you arrived at the numbers you have in your flight planning here.
For the takeoff distance chart, I had to know the pressure, altitude, and temperature in Celsius. I found gross weight in the first column, then I found the pressure altitude column corresponding to the weight. Ground roll was 765 feet, and total distance to clear a 50-foot obstacle is 1,420 feet. I have a headwind component of 10 knots, so I decreased those distances by 10%. I did the same for my departure from ABI. These distances are well within the available takeoff field lengths of both airports.
Besides the adjustments you made for the headwind, what other factors will change the required takeoff distance?
The notes on the chart indicate the stated performance is achieved using a short field takeoff procedure, flaps at 10 degrees on a paved level dry runway.
Okay, how did you calculate your time, your fuel, and distance to climb to your cruise altitude?
Okay, I located the departure airport pressure altitude and noted the time, fuel, and distance to climb values. I also adjusted the values by 10% for non-standard temperature. Then I obtained time, fuel, and distance values for my final cruise altitude, also adjusting for non-standard temperature at altitude. By subtracting the departure values from final cruise altitude values, I determined the amount of time, fuel, and distance to climb to my cruise altitude.
Not bad. Any special notes for the time, fuel, and distance to climb chart?
Yes, I must increase time, fuel, and distance by 10% for each 10 degrees above standard temperature, and all distances shown are based on no wind conditions. I adjusted for those, as you can see here.
Now, how did you get your numbers from the cruise performance chart?
First, I located pressure altitude, then the engine RPM I intend to operate at, and noted the true airspeed and fuel consumption rate for that altitude.
And the landing performance chart, what did you find out there?
The runway lengths are more than adequate for us today. Adjusting for the 10-knot headwind on landing, a ground roll of 480 feet, and I'll need 1,094 feet to clear a 50-foot obstacle.
Okay, let's talk about how you calculated the amount of fuel we'll need for today's flight.
Well, I used the airplane's cruise performance chart to determine an approximate fuel consumption during the climb, en route, and descent phases of flight. I don't know for sure this airplane burns exactly that amount, and we'll have a better idea when I refuel as to how close the charts are to the actual gallons per hour burned.
How did you arrive at the total fuel burn figure?
As indicated in this section of my flight log, I calculated 10 minutes and 1.5 gallons for taxi and takeoff, 11 minutes and 1.6 gallons for the climb to my en route altitude, 1 hour and 6 gallons used for en route cruise, 10 minutes and 1 gallon for the approach into Abilene, and another 30 minutes and 3 gallons of gas for the VFR day reserve. This adds up to a required fuel figure of 13 gallons.
Looks like we have more than enough fuel for today's flight. But what are several factors that may affect the accuracy of your calculations?
Winds aloft can have the most significant effect. If a headwind exists that wasn't forecast, the time en route increases along with the amount of fuel required. Also, whether or not I choose to lean the mixture during flight, the condition of the engine, the percent horsepower I actually operated at, all affect the amount of fuel burned.
Okay, what about crosswinds? Show me how to calculate the crosswind component for the airplane today.
My takeoff will be from runway 34 and departure time wind is forecast to be 340 at 10 knots. Since the wind direction and runway direction are the same, I won't really have a crosswind component, only a headwind. I used the crosswind component chart in the POH. If the wind direction were different, I would enter the chart at the appropriate relative wind angle and follow that line until it intercepted the wind velocity line. I can read the headwind component on the right side of the chart and the crosswind component at the bottom of the chart.
Just a couple more questions. How does weight affect takeoff and landing performance?
Well, increased gross weight results in a higher liftoff speed, a slower acceleration, more drag and ground friction, and a longer takeoff distance. On landing, the airplane will require a higher speed to support the airplane at the landing angle of attack and lift coefficient, resulting in longer landing distance.
Explain the significance of load factor.
Load factor refers to the effective airplane weight increase that happens as a change is made to its flight path and centrifugal force is encountered. Since an object in motion wants to stay in motion, any displacement from that condition results in a force being imposed on the airplane. The term for this is a G. A load factor of 2 Gs means the airplane and occupants effectively weigh twice as much as they normally would.
And maneuvering speed, what's its significance?
This is the speed below which any additional load factor imposed upon the airframe will only cause the airplane to stall. Above VA, you can cause structural damage if any additional loads are imposed.
How is the VA or the maneuvering speed affected by changes in aircraft weight?
VA will go up with an increase in weight. For example, it's 92 knots at 2,000 pounds in the airplane we're flying today and 99 knots at 2,400 pounds. The reason for this is that VA is tied directly to stall speed. As more weight is put on board, stall speed increases because more lift is required to hold the wing up. This is lift that won't be available as the wing approaches the critical angle of attack. Since VA is the speed at which the airplane stalls rather than bends, it will go up too.
Okay, let's talk some more about weight of an aircraft. What is significant about weight and balance of an airplane?
Weight refers to the basic empty weight of the aircraft plus everything else that might be placed in it, such as fuel, passengers, and baggage. It's important we don't exceed the gross weight defined in the POH. Balance refers to the location of the center of gravity of the airplane and is important to airplane stability and safety of flight. The CG is a point at which an airplane would balance if it were suspended at that point.
How would you find the center of gravity location?
I use a memory jogger called WHAM, which is weight times arm is equal to moment.
Okay, Robin, how would your airplane performance be affected by an overloaded aircraft?
A bunch of ways. I'll have a higher takeoff speed, longer takeoff run, reduced rate and angle of climb, lower maximum altitude, shorter range, reduced cruising speed, reduced maneuverability, higher stalling speed, higher landing speed, longer landing roll, excessive weight on the nose wheel. Not a good effect on performance at all.
I would definitely say we want to avoid doing all of that then. Okay, tell me how rearward and forward CG affects the airplane's flight characteristics.
With a forward CG, I'd have a higher stall speed, slower cruise speed, it will be more stable, and I'll need to use greater back pressure on the yoke. With a rearward CG, I have a lower stall speed, higher cruise speed, it will be less stable.
Great. Okay, now tell me about weight and balance calculations you did for today's flight.
I prepared a weight and balance analysis using full fuel for the airplane, myself at 120 pounds, you at 180 pounds, and 40 pounds of baggage. Based on these numbers, we're well within the center of gravity envelope for the airplane and haven't exceeded maximum takeoff weight, although we are close on the weight. I used the graphs and tables provided in the aircraft flight manual to calculate the weight and balance for this flight.
What's involved in this calculation?
First, I listed the weight of the aircraft, occupants, baggage, and fuel using 6 pounds per gallon for the weight of the fuel. Then I entered the moments for each item listed. I obtained these moments by using the loading graph provided in the aircraft flight manual. I then totaled up the weights and moments. Then, using the center of gravity moment envelope chart, I plotted a line for total weight and a line for total moments. The line intersected within the envelope, indicating the aircraft is loaded within limits.
Now, during the flight, we're going to burn off fuel, and will that weight change due to the reduction in the fuel load cause our CG to change?
Yes, there will be a change, but very minor because the arm of the fuel tanks were designed to be pretty much right at the CG. But I did calculate the new weight and CG for the aircraft as it approaches our destination, and the chart still indicates we'll be within the CG envelope.
Let me take a look here. Looks like all your calculations are correct. Okay, let's move on and talk a little more about aerodynamics. Explain to me what causes a stall.
An airplane stalls when the critical angle of attack has been exceeded. When you get the angle of attack to about 18 to 20 degrees, the air can no longer flow smoothly over the top of the wing, and you stall.
Okay, so this occurs when the airplane's just too slow?
Actually, it can happen at any airspeed, any altitude, and with any power setting.
What about spins? What are these?
A spin is when the aircraft descends in a spiral while flying at an angle of attack greater than the angle of maximum lift. They usually occur due to an aggravated stall in either a slip or skid.
So, Robin, what would you be doing to cause a spin?
I could enter a stall with excessive or insufficient rudder, or to a lesser extent, aileron.
When is a spin most likely to occur?
A few common scenarios where a spin could occur are: 1. If I have an engine failure on takeoff during climb-out. I need to be careful not to stretch the landing glide by applying back pressure and not try to make an uncoordinated turn back to the runway at low airspeed. And 2. When I turn from base to final and in a slip or skid configuration. This might be due to overshooting final because of crosswind conditions and then trying to make an uncoordinated turn at a low airspeed. 3. If I have an engine failure on landing approach, I have to be careful not to stretch the glide by pulling back. And finally, on go-arounds with full nose-up trim or with improper flap retraction.
What factors, Robin, contribute to the left-turning tendencies in an airplane?
There are several of them. First of all, torque, where the rotation of the crankshaft and propeller tries to roll the airplane in the opposite direction due to the physics of action and reaction. Then there's spiraling slipstream, where the air flowing behind the prop twists in a corkscrew shape around the fuselage. This air pushes on the vertical tail and yaws the nose to the left. Then there's P factor, where the downward moving propeller blade in a climb pitch attitude has a higher angle of attack and therefore more thrust on that side, which consequently yaws the nose to the left. Oh, and then there's gyroscopic effect, where the nose of a tail dragger yaws to the left on takeoff as the tail is brought up. As the tail is brought up, a force is applied to the top of the spinning disc of the prop, which transfers 90 degrees ahead in the direction of rotation. In other words, this precession tries to pull the airplane's nose to the left. For all of these, I counter it with additional right rudder.
Okay, Robin, I feel pretty good that you know how to determine the performance and limitations of your airplane.
Robin continues to demonstrate her operational understanding as a private pilot. In addition to this discussion, be prepared to both explain the significance of the V-speeds as well as define what they are for the airplane you're flying, either during this pre-flight briefing or during flight. You'll also want to have an explanation ready for how you'll estimate gliding distance in case of an emergency. Refer to your airplane's POH or Pilot Operator Handbook for this data. Track 5, Airplane Systems. The examiner confirmed Robin's ability to determine the airplane's flight parameters for today's conditions. Now he's going to test Robin's operational understanding of the mechanics involved with flying an airplane.
Robin, let's talk about what's involved in flying an airplane. Tell me, how are you going to use the flaps?
Well, flaps are movable panels on the inboard trailing edge of the wings. They are hinged and can be extended downward into the flow of air beneath the wings to increase both lift and drag. What they do is allow a slower airspeed and a steeper angle of descent during a landing approach. I can also use them to shorten the takeoff distance. So I'll use them on landing and to demonstrate a short field takeoff.
What hydraulic systems are on this airplane?
Hydraulic-wise, we have the braking system, the nose strut, and the nose wheel shimmy damper.
How do you steer this airplane when you're on the ground?
This airplane has a nose wheel steering capability. It's basically a simple mechanical linkage with the rudders. When I press down on a rudder pedal, a spring-loaded bungee or push-pull rod connected to the pivotal portion of the nose wheel strut turns the nose wheel.
And what type of engine do we have in this airplane?
The Cessna 152 is equipped with a horizontally opposed 4-cylinder overhead valve air-cooled carbureted engine. It has 110 horsepower and is made by Lycoming.
And speaking of carbureted, what does a carburetor do?
A carburetor basically mixes fuel and air in the right proportions to form a combustible mixture. It vaporizes fuel into small particles and then mixes it with air. It also measures the airflow and meters the fuel.
So what's the significance of icing when it occurs in a carburetor?
The significance is it can make my engine run rough or even quit. I need to be alert for it when the temperature is between -5 and 20 degrees Celsius, which is about 70 degrees Fahrenheit, with high humidity or visible moisture, or when the dew point and temperature are close together, and particularly when I have the throttle low or closed. Anytime I have the power below the green arc, I want carb heat on. I do this by operating the carburetor heat valve, which directs unfiltered heated air into the induction air manifold before it gets to the carburetor. I'll watch the RPM. There should be a slight drop, then a rise again once the ice is all gone, and then the engine should run smoother.
What would you do about a partial power loss in flight?
Whether it's a partial power loss or a complete power loss, I'd set up a glide at my best glide speed of 65 knots and find a good spot to land. Then flying toward that area, I'd try to restart the engine by applying carb heat, cycling the fuel selector, bringing the mixture to rich, cycling the mags, and checking that the primer was in and locked.
What about an engine fire? What would you do if that developed in flight?
Right away, I'd want to eliminate any source of combustion. I would pull the mixture to idle cutoff, switch the fuel selector off, and turn off the mags. Then I'd pitch down to at least 100 knots, attempting to blow out the fire and find a good field to put the plane down in.
I really don't think either of these things are going to happen today, but it's always good just to have a plan, just in case. Now, what do throttle and mixture controls do?
The throttle controls the amount of fuel or air charge entering the cylinders, which regulates the engine's speed and power. The mixture controls whether the fuel-to-air ratio is too rich or too lean. This lets me adjust the mixture at high altitude as the air density is decreasing. I can also lean the mixture during cross-country flights to conserve fuel and provide optimum power.
Okay, Robin, on this airplane, the Cessna 152, is the propeller a fixed pitch or variable speed propeller? What's the difference?
We're flying a fixed pitch propeller, which means the pitch of the prop is fixed by the manufacturer and can't be changed by the pilot. The propeller is mounted on a shaft, which is an extension of the engine crankshaft, so the prop RPM will be the same as the engine RPM. An airplane equipped with a constant speed prop has a governor which is continuously adjusting the propeller blade angle to maintain a constant engine speed. If engine RPM increases as a result of a decreased load, like in a descent, the system automatically increases prop blade angle, which increases air load until the RPM has returned to a preset value. This type of prop is more efficient in various flight conditions.
Okay, describe for me the type of ignition system on this airplane.
The ignition on this aircraft is provided by 2 engine-driven magnetos and 2 spark plugs per cylinder. The system is completely independent of the electrical system. The magnetos supply the current without any external source. To get them started, a battery is used to operate a starter, which cranks the engine.
All right, tell me about the fuel system on the Cessna 152.
It's a gravity feed system. Using gravity, the fuel flows from 2 wing tanks to a fuel shutoff valve, which if turned on, allows fuel to flow through a strainer and then to the carburetor. The fuel is then mixed with air and goes into the cylinders through intake manifold tubes. It holds up to 40 gallons of usable fuel with extended range fuel tanks.
And so why do we need to have fuel tank vents in this airplane?
Venting prevents a vacuum from forming in the system, which would prevent the flow of fuel by gravity.
And speaking of fuel, what kind of gasoline does this aircraft use?
The approved fuel grade is 100 octane low lead, which is colored blue. It is possible to use 100 octane fuel, which is colored green, but I wouldn't normally do so. If red fuel, which is 80 octane, were found in the tanks, that would be a no-go item.
Okay, Robin, how about the same question, this time for oil?
Multi-viscosity SAE 10W30 ashless dispersant oil. It holds 6 quarts, and I should never let it go below 4 quarts.
Okay, how about describing the electrical system in this airplane?
It's a DC system that runs off an engine-driven alternator that provides 60 amps of current. It uses a 24-volt battery, but the alternator actually provides 28 volts because there is extra energy needed to keep the battery charged.
And how about the ammeter? What does it indicate to you?
It basically indicates the flow of current in amps from the alternator to the battery or from the battery to the electrical system. If my alternator goes offline and is no longer functioning, or the electrical load exceeds the output of the alternator, it would then show the discharge rate of the battery.
Okay, one more question. You're flying along and all of a sudden accidentally the master switch is turned off. Would that have an effect on the aircraft systems?
Well, turning off the master switch will turn off all the electrical equipment on board the aircraft, including the nav and comm radios, lights, etc. The engine will continue to run normally on the magnetos.
Okay, what can you do if you get too cold or warm in the aircraft?
There is a cabin air control which essentially routes fresh air in through vents, and a cabin heat control which routes outside air over the exhaust manifold that gets piped into the cabin. If we use heat, we need to watch the carbon monoxide button because there is a danger in that any exhaust leak will bring carbon monoxide into the cabin.
Okay, we've kind of shifted gears here and now we're inside the cockpit. So let's talk about some of the instruments. What are the instruments that use the pitot-static system?
The altimeter, vertical speed, and airspeed indicators. Only the airspeed indicator uses input from the pitot tube.
So explain to me how the altimeter works.
Inside this device, there are aneroid wafers that expand and contract as the atmospheric pressure changes, sort of like a balloon. Then through a shaft and gear linkage, pointers on the dial are rotated.
So if you change the altimeter setting, say from 29.15, or let's say to 29.85, what change is going to occur?
The altimeter will indicate a higher altitude. Changing the altimeter setting by 1 inch of mercury equals about 1,000 feet of altitude change. A higher altimeter setting gives you a higher altitude readout. A lower setting gives a lower readout.
Okay, how about the airspeed indicator? How does that work?
It compares the dynamic pressure of oncoming air hitting the pitot tube against the density of static air sensed at the static port. As the dynamic air input increases, it expands a little sealed capsule inside the instrument, which then drives a pointer on the face of the gauge.
All right, tell me about the various colors you see on the airspeed indicator and what they mean.
Well, let's see. The white arc represents the flap operating range. The lower airspeed limit of the white arc is VSO, or stall speed in the landing configuration. The upper airspeed limit of the white arc is for VFE, or maximum flap extension speed. The green arc indicates the normal operating range. At the low airspeed end of this green arc is VS, or stall speed clean. At the upper airspeed limit of the green arc is VNO, which is normal operation speed, or maximum structural cruise speed. The yellow arc indicates the caution range for operating in smooth air. The red line, or VNE, is the maximum speed for operations in smooth air.
Now, what instruments have gyros?
The turn coordinator, heading indicator, and attitude indicator. Usually the turn coordinator is electric and the other two are vacuum driven, although all three can be electrical.
Oh, very good. Now, while we're talking about the vacuum systems, how do they operate?
An engine-driven vacuum pump draws air through the instrument cases of the attitude indicator and the heading indicator, and then is vented outside. This air is directed at the gyro rotors to spin them up to their high speed. The output of the pump can be monitored on the suction gauge, which usually has a green arc of about 4.5 to 5.5 inches of mercury.
Okay. What can you tell me about compass errors?
Well, there are 5. Oscillation error, which is caused by turbulence. Deviation error, caused by electrical or magnetic disturbances in the aircraft. Variation error, which is due to the angular difference between true and magnetic north. I refer to the isogonic lines of variation for this. Acceleration error occurs on east or west headings while accelerating or decelerating. I use the memory jogger ANS, which stands for accelerate north, decelerate south. Northerly turning error, which occurs due to the compass leading in the south half of a turn and lagging in the north half of a turn. Another memory jogger here is UNOS, which stands for undershoot north, overshoot south.
Robin, let's talk a little bit about system problems and emergencies for a moment. What would you do if you ran into detonation?
Well, detonation occurs if the engine was overheating or running rough, or I found the fuel and air mixture was too lean. I'd reduce both the temperature and pressure of the fuel-air charge by reducing power, reducing the climb rate for better cooling, enriching the fuel-air mixture, or by opening cowl flaps if available. Also, I'd make sure the proper grade of fuel has been used.
Okay, I have a hypothetical question for you. During your run-up and before takeoff, you switch the magnetos from both to right setting and notice no drop in RPM. What's going on?
One of two things. Either the left P-lead isn't grounding, or the engine has been running on the right magneto only, as the left magneto has totally failed.
Okay, I have one more question for you. What would you do about an ammeter indication that's showing a continuous discharge in flight?
Well, first I would turn off the electrical equipment and then cycle the master switch in case it was a nuisance trip, taking the alternator offline unnecessarily. If the discharge continued, then I would switch the alternator side of the master switch off and pull out the alternator field circuit breaker. Assuming it was daytime, I would leave off all the non-essential equipment and fly to the nearest field where repairs could be made. At nighttime, I wouldn't assume I had any more than about an hour of battery life.
Robin, you know your airplane very well.
Robin continues to shine. Notice how the examiner only touches on each of the systems and instruments. It's unlikely the examiner will grill you on every possible scenario. The best preparation for these questions is to become intimately familiar with your airplane's POH. It's likely the examiner will ask some of these questions during your pre-flight inspection, so he or she can see how you correlate the POH to the airplane on the tarmac.